Now we will continue chapter 5 of commercial mechanical inspector exam test N2. We will continue in vent. Recommended study time it is 240 minutes. For module 5 the required references is International Mechanical Codes is 2021 or later, no problem. It is in chapter 8 and international fuel gas it is in chapter 8 also. Vents. We are highly regulated and we need to understand the scope and complexity of this regulation in our code reference. This is the vents. Illustration 5a vents. The intent of vent is to completely remove products of combustion while minimizing hazard associated with high temperature and toxic corrosive combustion gases.
IFGC Chapter 5. This module will teach regulations for vents, their connections to solid and liquid fuel burning appliances. This chapter in the IFGC covers both chimneys and vents for fuel gas appliances. In the International Mechanical Code, Chapter 8 covers chimneys and vents for appliances fired by other fuels. We're going to split the topic into two modules because what we need to cover for vents is long enough. This module covers vents, and the next module will cover chimneys.
Chimneys versus vents versus flows. Most of us have seen all of these, but what is the real difference between the three? Let's look the identification from International Fuel Gas Code, Chapter 2. Definition together now. Defining terms. A chimney is a primary vertical structure containing one or more flues for the purpose of carrying gaseous products of combustion and air from flue-burning appliance to the outdoor atmosphere. Defined terms. A vent is a pipe or other conduit composed of factory-made components containing passageway for conveying combustion products and air to the atmosphere, listed and labeled for use with a specific type of class of appliance. Defined terms. Flue is a passageway within chimney or vent through which gases combustion products pass. Chimney, masonry, factory built, vent, P-vent, L-vent, pellet vent. Here this is the masonry. This is the masonry chimney. Illustration 5b chimneys and vent and flue. Both chimney and vent carry products of combustion to the atmosphere, and so do flues. But flues are simply the opening inside of chimney and vents. And chimneys can have more than one flue. This chimney has 4 flue. The one on the left had been filled with concrete. This one is filled with concrete. Fast facts. Vents will only have one passageway.
The stack effect. Chimneys are primarily vertical and rely on chimney or stack effect, the movement of air from air buoyancy, or in other words, the movement of air is because hot air rises. Note that vents can not only be installed vertically, but horizontally as well. Distinctions between vents and chimneys. The most important distinction is that vents are, quote, listed and labeled for use with a specific type or class of appliance, end quote, while chimneys usually are not. Chimneys must be used for solid burning appliances with the exception of a pellet stove, which can use a pellet vent.
Appliance vent. International Mechanical Code 2021, Chapter 8, Section 801. And the International Fuel Gas Code 2021, Chapter 5, Section 501. With only a few exceptions, like certain appliances, and where is less than 20 BTU per cubic. Okay, so in this case only, if we have appliance that have less than 20 BTU per hour per cubic foot of space, most fuel burning appliances must vent the products of combustion to the outdoor. This is the only exception that we have. For venting categories, there are 4 categories for venting system for appliances. These categories are based on combustion of temperature, above or below dew point, pressure, negative or positive. Defining terms. Dew points is the air temperature, or in this case, flue gas temperature, whereas the air becomes saturated with water vapor. This is to say, if the temperature drops below the dew point of the air cannot hold onto its water anymore, and the water will come out as droplets on surface as fog or rain. As we see here, this is illustration 5C, appliance venting categories. As we see here, flow under negative pressure and flow under positive pressure. Here, flow gas temperature will above dew point, flow gas temperature at or below dew point. And here is this category I. As we see, we can use B or L, double wall vent or chimney. So we can use this table for appliance vented category, the category 1, 2, 3, 4. Okay, so category 1, we are using P or L, double wall vent chimney. Category 2, not commonly used, corrosion or resistant material. Category 3, sealed stainless steel. Category 4, sealed stainless or plastic. This illustration is a table that shows the combination, category, numbers, and material used for each of 4 venting categories.
Positive pressure in the flue. The only way to have a flue under positive pressure is to have a fan at the appliance, pushing the products of combustion through the vent in categories 3 and 4. The fan comes with the appliance and is sized by the manufacturer, and thus the manufacturer specifies sizes, lengths, materials, and methods for venting the appliance.
The 2 ways to get negative pressure, there are 2 ways to have a flow under negative pressure. 1, through a chimney effect. 2, having a fan at or near the discharge of vent. For the chimney effect to work, the gases must be hotter than the surround to get the hot air to rise.
Dealing with cool flue gases. A category 2 appliance has cool flue gases, which means the chimney effect won't work. The only option is to have a fan, also known as a power exhauster, at or near the vent discharge. A separate fan outside of the appliance does create difficulties for manufacturing, shipping, installation, and maintenance. This is why category 2 appliances are rare.
Understanding the code. Because of the above, category 1 appliances are the only ones that have vents that are sized and specified by code requirements. All other are to follow the manufacturer installation instruction, including category 2 vent. Vent material. This is International Mechanical Code 2021, sections 802, and International Fuel Gas 2021, section 502. Illustration 5D, type P vent, this type P vent, and type PW vent. Type B and PW vents are used for gas. The B vent is a double wall vent system with joints that snap together. The PW is an oval P vent built to fit inside of wall cavities intended for wall furnace. Illustration 5E, type L vent. The type L vent is used for solid and liquid fuel appliances and is like the B vent, except the L vent has stainless steel inner wall. Illustration 5D, sealed stainless steel vent. Sealed stainless steel is mainly used for category 3 appliances, but can also be used for category 2 and IV, this is category 4 appliances. The manufacturer Z-Flex has named their product the Z-Vent, but this is simply a brand name, not an actual vent type. The vent is commonly sealed with gasket or welds. Z-Vent. Illustration 5G, plastic vent piping. Plastic vent piping is only permissible for category IV, category 4, and only as specified by the manufacturer instruction. Venting installation, it is International Fuel Gas Code 2021, section 503. Remember that the purpose of venting appliance is to remove all gases to the outdoor to a location that will not negatively affect health or be a nuisance. Leaking flue gases into the building need to be avoided. For most appliances, following the manufacturer installation instruction is sufficient. Let's take a look at what appliances and system for which the code instructs us to simply follow the manufacturer recommendation. Study tape code references the manufacturer for installation. Direct vent appliances, appliances with integral vents, appliances draft requirement, mechanical draft system. In order to prevent flue gases from leaking into an indoor space, the code regulates system equipment location. Let's look at this highlight list. Guidelines giving for complete flue gas removal. Natural draft venting cannot be combined with mechanical draft venting. The mechanical draft system must be proven to be on before gas can flow to burners. Exit terminals of mechanical draft system must be at least 7 feet above walkway. Venting system cannot pass through air duct of furnace plane. Understanding the field. If a vent system is installed in a way that look like flue gas will come back into the building, or you can detect the flue gases are coming back into the building, the installation and or material are probably not code compliant. Fast facts: Industrial applications with large, well-ventilated space is the only exception where the flue gases can be discharged inside the building. This is appliances, as this is the type of venting that we will use. Okay, you can check this one. For example, listed category 1 appliances, listed appliances with draft hood, appliances listed for use with P vent. We will use here P vents or chimney or single wall metal pipe chimney lining system, special gas vent listed. Listed vented wall furnace type PW vent. Category 2 and 3 and 4 appliances follow manufacturer instruction. Listed combo gas and oil appliances, it is type L chimney. Appliances that can be converted to solid fuel, we will use chimney. And unlisted combo gas and oil appliances, combo gas and solid fuel appliances combination. Appliances listed for use with chimney only. Unlisted appliances, decorative appliances is vented fireplace, all this use chimney. Illustration 5D is a summary of International Fuel Gas Code Table 503.4. The types of venting system to be used in listed in International Fuel Gas Code Table 503.4 is we have created summary of the table. Feel free to refer back to this and need it during your study of this module. Gas vent termination. It's International Fuel Gas 2021 section 503.6.5, 503.8. As we see here, illustration 5G gas vent termination, height and diameter. For less than 12-inch diameter, H from table 503.6.5. Okay, or greater than 12-inch diameter, we see here 2 feet and here far 10 feet. For diameter 12-inch or less, terminate above the roof per figure 503.6.5. For diameter larger than 12 inches or when using an L vent, terminate at least 2 feet above any portion of building within 10 feet horizontally. All termination must be at least 8 feet away from vertical wall. Study tip: you are probably not going to remember all of the various distances required for vent termination, and we don't suggest you try. Yet it almost a guarantee that at least one question on the test will be about vent termination distance. So it is important you know where to find information for each scenario. The gas vent termination height can also come from following the manufacturer installation instruction or by using approved engineering practice. Termination height for roof slope, for flat roof, or until 6 by 12. H minimum it will be 1, okay, for 12 inches. Okay. Illustration 5G comparison of vent termination height. This table adopted from International Fuel Gas Code shows the minimum height from the roof to the lowest discharge opening for vent 12 inches or less from figure 503.6.5 and greater than 12 inches from section 503.6.5 item 2. Think about it. Going from 12-inch vent to 14-inch vent will increase the height of the vent by an average 8.5 feet or by about 4 times. Illustration 5D gas vent termination height type P, L, or L and PW. Okay, here for highest connected appliances, as we see here, this type L, P or L vent, it must be more than 5 feet. And here this wall furnace and connected to type PW vent. Here the height, it must be 12 inch. Type P or L vents must be terminate at least 5 feet above the highest connected appliances or flow. And type PW must terminate at least 12 feet above the bottom of wall furnace. As we see here, this through the wall vent terminal clearance. This from figure 503.8 from International Fuel Gas Code. And this here is the figure clearance and clearance location. Okay, from window or door or something, and this is a minimum clearance. If the appliance is less than 10,000 BTU per hour, it will be 6 inch, and the clearance will be 9 inch if it is more than 10,000 and less than 50,000 BTU per hour. It will be 12 inch if its appliances is more than 50,000 and less than or equal 150,000. Okay, this is the through the wall vent terminal clearance. Illustration 5L, through the wall mechanical draft vent location. Vent must be at least 3 feet above any forced air inlet located within 10 feet, at least 4 feet below, 4 feet horizontally, and 1 feet above any door, openable window or gravity air inlet, and at least 12 inch above finished ground level. Direct vent can be closer for appliances with an input rating less than 150,000 BTU per hour. See table 503.8. Category 2 and 4 appliances vents. Category 2 and 4 appliances termination have more restrictions. They cannot be located over an area where is condensate or vapor could create a nuisance or hazard. Vent drain are required but will be installed according to the manufacturer recommendation. Fast facts. Category 4 termination must be 10 feet horizontally from any operable opening in all adjacent building or be at least 2 feet above or 25 feet below the opening. Single wall vent pipe. This is an international fuel gas code 2021 section 503.7. There are provisions for using single wall vent pipe for category 1 appliances, but it is generally not recommended by industry professional. For more detail on this, or if it comes up on the exam, you can reference International Fuel Gas 503.7, draft hood and draft controller. International Fuel Gas Code 2021 section 503.12. We find this statement in the code, and it reads like this. Vented appliances shall be installed with a draft hood, and then follows up with large list of exceptions. To better understand the exception and when a draft hood would be required, it is important for us to first understand the function of a draft hood and what it's used for. Illustration 5N, draft hood. You have probably seen the draft hood on a residential gas water heater at the top of the tank. When dealing with category one furnace draft hood are often built-in. Understanding the physics of air. As we have mentioned previously, hot air rises, the hotter air is in comparison to the surrounding, the faster it will rise. The hotter the air is in comparison to the surroundings, the faster it will rise. Think about it. What does this mean for residents using a chimney? As the temperature conditions change, air will be pulled up through a chimney and a vent difference rate.
The effect of the draft hood. When an appliance is burning gas, it is producing hot combustion gases. The code gives limits to vent sizes and lengths, but allows for a wide variation. Hot gases go up the vent, pulling in air from the bottom. Without a draft hood, that air would have to go through the burner, causing the flame to burn hotter. Controlling the gas input would no longer control the heat input. Now introduce a draft hood. The draft hood makes up the difference between what is going up the chimney and what is being produced by the appliance by pulling in some of the room air with the exhaust stream. The draft hood makes it possible to draw more or less air into the exhaust system without affecting the heat produced by the combustion.
Understanding the code. The way this principle is normally expressed in the code is with the intent to achieve no difference in pressure between the hood and the combustion air supply. The reference is International Fuel Gas Code section 503.12.5, for example.
Appliances not needing a draft hood. The list of exceptions for a draft hood include appliance types that have a way of controlling exactly how much combustion gases are exhausted. Added features such as power vents, direct vents, fan-assisted combustion, pressure burners, to name a few, or systems that have other ways of taking in extra air, such as a range.
Here is the parametric regulator. Illustration 5N parametric regulator. A parametric regulator serves the same purpose as the draft hood, but includes a mechanical function that closes as the vent flow decreases. The parametric regulator will actually regulate the amount of combustion air that is brought into the appliance and is typically only used on fuel oil appliances. Based on the purpose of the draft hood, the requirements for it make sense. Installed in the same room with the appliance. Opening not obstructed. Number 3 with a proper clearance.
Dampers and other obstructions. Manually operated dampers and other obstructions are not allowed in vents for any appliance. But of course, as is nearly all of the time with codes, there are a handful of exceptions to this regulation. You can read more about it in your IFGC section 503.15.
Gas vent sizing. International Fuel Gas Code, this 2021, sections 503.6.10.504. Category 1 appliances on the same floor. When sizing an individual gas vent for single appliance with draft hood, the effective area of the vent need to be between 1 and 7 times the size of the draft hood. Outlet study tip. This will likely be one of the most complex areas of study within this course. However, don't feel like you need to understand it fully or be able to replicate the complex sizing example. This is the process by which vents are sized, and we present it for those who are interested in this level of detail. If you are interested, take your time and don't rush through the rest of the module.
Working through our vent sizing example. Read through our following steps carefully. We are here to help as needed, but you may need to read through our examples several times, and we recommend this to lay a solid foundation of understanding. Then, if you need help, our coaching responses will make more sense to you so you can grasp this and move on. For the purposes of the test, you should know where to look up information and how to do the simple calculations. Our quiz questions and sample tests will help you realize the level of understanding required. Let's get into it.
Illustration 5.0 Vent size for 2 appliances with draft hood. This is a draft hood, and this is the 2 appliances connected together. When sizing a gas vent for 2 appliances with draft hood, the effective area of the vent need to be between 1.5 times the size of the larger draft hood and 7 times the size of the smaller draft hood. Offset. Type P and L vents are allowed only on offset greater than 45 degree but not less than 60 degree. All other offsets must be less than 45 degree. Understanding design. Any section of the vent greater than 45 degree from vertical is considered horizontal. For draft hood appliances, the horizontal distance include any connector cannot be more than 75% of the vertical distance of the vent. Category 1 appliances on more than one floor. According to the code, appliances must be in room separate from occupable space if they are connected into the same vent for multiple floors. When this is the case, use table 504.3.1 for code compliance. Sizing category 1 appliance venting system. International Gas Code 2021 section 504.
Sizing in category 1 appliances. Remember that the code only talks about sizing venting systems for category 1 appliances. Category 1 appliances can have a fan-powered exhaust, but the venting system typically relies on gravity and density differences to pull hot gases out of the vent. Remember the chimney effect. Condensation cannot occur in category 1 appliance vents because the gases need to stay hot to rise out of the vent. For categories 2 through 4, follow the manufacturer's instructions.
Understanding practice. The vent needs to be sized so that the pressure inside the vent is less than the space outside the vent. The pressure difference is caused by the air rising out of the stack. If the vent diameter is too small or much too large, a chimney effect will not occur. Note, the vent diameter in the table is the minimum permissible. The size can be larger to a point but cannot be smaller. Using the tables. The tables are arranged with the assumption that the vent dimensions are already known, diameters, height, and length, and the reader is figuring out how much capacity can be connected. Study tip. To design a vent for an appliance, the tables must be used backwards to how they are set up. Understanding the code. The way the tables are set up is useful for inspections and therefore makes possible test question a lot simpler than what designers have to go through. And what we are about to go through is the size, to size the vents. Which table used to size vents? This is the table of tables, this vent type, and this is the connector type, and this is number of application connected. So we will use this table. Okay. Illustration 5b, table of tables, vent sizing. You will find the table useful in order to find the code reference table to use for sizing vents. Study tab. Important note on the table 504.2. 5 is for draft hood equipped appliances only. 504.2. 6 is for natural draft appliances only. 504.3. 5 is for draft hood equipped appliances only. 504.3. 6 is for natural draft appliances only. 504.3. 7 is for fan and natural draft appliances only. Study tip. In this module, we will only look at type P vents referenced in table 504.21, 504.22, 504.31, and 504.32. The other tables can be applied in similar fashion for chimney and single wall vents. Sizing vent for single appliances is International Fuel Gas Code 2021, section 504.2. Let's practice sizing. We are going to go walk you through an example step by step for natural draft furnace. Take your time with this. Study tip. The order of how these steps are applied generally doesn't matter. In fact, the order the steps are presented here are dramatically show the effect each step has on the vent sizing, which means that it may be most complicated order. Just do your best to follow along, and remember that the purpose of the example is to go you familiar with the table along with individual venting requirements. Example, we have a natural draft furnace with an input rating of 100,000 BTU per hour. We are using a type P vent with a type P connector. What table will be using? We will use table 504.21. Study tip. Follow along in the tables in your code and see how the extent of our highlighting progresses in the illustration through this example. Our highlighting represents what options are still available as we walk through each step and narrow down the option. This will give you a visual of our progression through the table until we arrive at the correct sizing. It's also give some insight into the through process so you can develop or refine your own table reading skill. Step 1, determine the maximum required. Find the input rating for the appliance which is listed on the appliance nameplate. In this case, it will be 100,000 BTU per hour. As we see, this is the narrowing by maximum required. As we see here, it's all maximum required. It's marked by yellow. Anything on the table with ANAT max or less than 100 in thousand of BTU per hour or NA can be estimated, which still leaves most of the table. Just this part is excluded. And all this included. Step 2, determine if is a minimum required. After step 1, most the options are still on the table, literally. If we are simply using natural, the draft, yeah, it's literally all the table is still with us here. There isn't necessarily a minimum for the various vent size, but there are a few scenarios that would require a minimum to be applied. Step 2A is the vent fan assisted. If yes, if it's greater than the step 2A, if yes, then the minimum vent capacity fan minimum cannot be above the appliance. And after this, we have this yellow. Illustration 5R, step 2A, accounting for the fan. Now we eliminate any section that has the fan minimum above 100. If a fan minimum is not a variable, the vent configuration is not permitted. If more than step 2B, will there be vent tampered? If yes, the minimum capacity for vent is the fan minimum again. Eliminate any section that has fan minimum above 100. If fan minimum is not a variable, the vent is not permitted for this scenario. You can reference this in International Fuel Gas Code 504.2.1. Note that this will be the same result as we saw from 2A. More than step 2C is the unit installed at high altitude. Installation at high altitude often required a high altitude kit from the manufacturer. It could also result in 2 to 4% less input for every 1,000 feet above 2,000 feet. Study tip example. At a 4,500 feet, the 100,000 BTU per hour could be as low as 90,000 BTU per hour. We get this from this calculation. This is 4,500 feet minus 2,000 feet multiplied by 4% divided by 1,000 feet. It will equal a 10% reduction. Note that that you will want to run the calculation and use the actual input as a minimum. In this case, it's 90,000 BTU per hour. Illustration 5S, step 2C, determining the maximum requirement. Now eliminate any selection that has a fan minimum above 90. You can reference back the International Fuel Gas Code 504.2.5 as you are following along if desired. If more than step 2D, does the application have a multi-stage burner? The fan minimum must be lower than the lowest application output. Study tip example. If our 100,000 BTU per hour furnace have 3 stages and can fire at 56% or 75% and 100%, the fan minimum must be lower than 56,000 BTU per hour. And this is the table. Illustration 5D, step 2D, factoring in multi-stage burner. Eliminate all configure with fan minimum above 0.9 multiplied by 56,000 BTU per hour. It will equal 50,400 BTU per hour. Yes, we are still assuming high altitude from 2C. You can reference back to International Fuel Gas Code 504.2.6 if desired. Study tip. At this point, take a few minutes to notice the patterns that are emerging in highlighted table, read through our notes below highlights these patterns. Study tip, important note about reading the table. As the height go up, so does the capacity of the vent, which brings the maximum up and minimum down. The chimney effect work better with a taller vent. Number two, at lateral distance increase, the capacity of the vent decreases. The maximum decrease and the minimum increases. Lateral venting creates more pressure drop. There is by decreasing the chimney effect. As vent diameter increasing, vent capacity increased as well. Also note that the minimum increasing for any vent that has a lateral distance. Fast facts. If we have a very small amount of hot air within a large diameter, it will not produce a great chimney effect. Step number 3, determine if there are any D rates to the maximum. Just as there are multiple scenarios that affect the minimum, several instances affect the maximum too. Let's look at this instance in step 3a through 3c. More than step 3a, does the vent need to have more than 2 elbows? When a setup has 0 lateral length, it means it has no elbows or effect or offset in the vent. Understanding design, lateral greater than 0 accounts for 2 elbows. If the vent requires more than 2 elbows, each below decreases the capacity of the vent based on the angle of the below according to our small table below. As we see here, for the angle from 1 to 45, the reduction it will be 5% of maximum capacity for table, and from 46 to 90 it will be 10% of maximum capacity for table. Study tip example: if the route for our furnace requires 2 or more than 45 elbows to avoid conflict and surround the construction, all vent configuration is in the table are below now capable of 90% of what they were. Okay, illustration 5u, step 3a, factoring additional elbows. Eliminate everything that has a maximum of 100 per 0.9, it will equal 111 or less in International Fuel Gas Code 504.2.3. Think about it. The reduction is 10% of maximum capacity from the table. In order to end with 100, we need 111 or more in the table. 0.9 multiplied by 111, it will equal 100. If the math doesn't not make sense, reference to the table again in light of this graphic. It would not make sense that adding elbow would allow us to use smaller diameter vents, which is what would happen if 90 were allowed as a maximum instead of 100. More than step 3b, are we using a corrugated metal chimney linear? If yes, then 20% reduction in capacity cure with accounts for one long sweep elbow at the bottom of the vent. Understanding and practicing. If the inside of the vent isn't smooth, pressure drop is increased and vent capacity is reduced. If there are more offsets, further reductions must be added. Refer back to step 3a. For our example, we will stick with a smooth type P vent and no D rate. You can refer back to International Fuel Gas Code 504.4.2.7 if desired. More than step 3c, if the vent size is smaller than the draft hood or floccular outlet size, the vent or connector can only be reduced if the vent height is at least 10 feet based on the draft hood or floccular diameter. Draft hood or floccular diameter per inch and the allowed reduction in vent size. From if the draft hood or floccular is 3 to 4 inch, no reduction allowed unless fan assisted. From 5 to 12, one table size. More than 12, up to 2 table size. Another permissible reduction if the vent or connector is reduced in size from the draft hood or floccular size, the maximum capacity of the vent is reduced by 10% of the listed maximum table capacity. Think about it. Using our example, if the floccular is 6 inch, the vent could be reduced to 5 inch. A 4-inch vent or connector would not be permitted because that would be a reduction of 2 table size. Illustration 5V, step 3C, smaller than draft hood or floccular. Let's eliminate all 4-inch vent selections first, and the 5-inch vent selections that are less than 100 by 08. It will give 125, refers to International Gas Code 500.04.2.2 if desired. Note that corrugated vent cannot be smaller than the floccular draft hood diameter.
Wait, 20%? You might be saying right now, hold on, you just took off 20%, not 10% like you said. Yes, this is correct. The D rates are additive. Since all D rates are based on the table capacity, we have to add all the D rate percentages together before determining the effect on the max capacity.
D rate recap. Let's recap quickly. We took off 10% in 3A and 10% in 3C. The total 20%, so we eliminate all 5-inch vent selection less than 125 in net maximum column. Step 4, determine if there are vent sizes not allowed. According to International Fuel Gas Code 504.2.11, a vent connector can be up to sizes larger than the floccular. Think about it. This doesn't eliminate size from our selection because the vent can still be larger, but it doesn't restrict the connector size from the appliance's outlet to the vertical vent. The vent can be up to 7 times the areas of the floccular or draft hood outlet. Reference International Fuel Gas Code 504.2.8 for this. In our example, the outlet diameter is 6 inch and the area is 3.14 multiplied by 3 by 3. It will equal 28.3 square inches. Let's do the same. Let's do some math with this area to determine what 7 times greater than will result on. Try and calculate this before revealing your answer. Show the answer. 28.3 multiplied by 7 will give us 197.8 square inches. This corresponding the maximum diameter of 2 multiply 2 by square roots, it will give 197.8 divided by 3.14, it will give 15.9 inch. Study tip. Calculate our bolded equation above on your own calculator. You can use this equation to convert an area giving in square inches to diameter of material enclosing it. Illustration 5W, step number 4, removing vent not allowed. Since the vent cannot be 16 inch or larger, eliminate all vents selection 16 or more. Step number 5, determining vent layout and dimension, understanding and practice. This may be occasion in the new construction where the mechanical room isn't quite determined for laid out yet on the drawing. In such case, it makes sense to do this step last. This way, one can see all the available options as we have done here. Most applications will have the layout and dimension fairly set, and this step would be near the first step. The example we are working on has 2 extra elbow in it. Refer back to the step 3A if needed. Important notes. The vent can still meet the requirements of 0 lateral if it stay more vertical than 45 through the entire length. We will assume that our vent had lateral offset plus the 2 extra elbow, which means that it can not meet the requirements of 0 lateral. Illustration 5x, step 5, factoring in for layout and dimension. All 0 lateral rows should now be eliminated.
Vent height dimension. The height dimension is going to be relatively fixed for most installations. There is an option to increase the vent height above a roof more than what is required, but only by less than 5 feet. This is stated in the IFGC section 504.2.9, and you can reference this as necessary.
In our example, we are going to assume the vent height is 17 feet. Because we are between 2 high enters, 15 feet and 20 feet, the values can either be interpolated or the worst case for both minimum and max has been taken. The higher value is used for minimum, the lower value is used for maximum. We will skip the mass of interpolation and use the worst case in reference International Fuel Gas Code 504.2.17 if needed. Think about it. Based on the options left on the table, the lateral can be between 2 and 10 feet, and the vent diameter can be between 5 inches and 9 inches. We can see this highlighted in illustration 5y. Illustration 5y, look at both options. We are now left with 15 feet and 20 feet. Okay, we have between 15 and 15. With the method we have utilized, the selection that we can use must be highlighted in both height enters since we are not interpolating. There are 2 more highlighted areas we can eliminate from the table since we are not interpolating the result. First, notice that the letter of 10 feet is highlighted from the height of 20 feet, but not for the height of 15 feet. Therefore, a 10-foot letter can not be used. Second, also notice that 9 inch vent diameter is highlighted for the height of 20 feet, but not for 15 feet. Therefore, a 9-inch vent cannot be used. Now, it's unlikely that the lateral is only 2 feet when we have 2 90 elbows and 2 45 elbows. However, for the sake of the example, we are going to assume it. Illustration 5Z, narrowing down to diameters between 5 inch and 8 inch. A lateral of 2 feet allow us any vent diameter for 5 inch to 8 inch because we are within the limit required for the size of the vent connector and the vent for all of the selection. We now arrived at the final answer of sizing option for our long-running example. The vent and vent connector can be vary in size between 5" and 8" for the entire length of the vent. Did you know the different material can be used along the length of the vent as well if each size and type are permitted by the table? International Fuel Gas Code 504.2.12.
Finishing this example. Wow, that was a long running example. Feel free to return to this to understand this process better. It is long and complex. But because we've broken it down for each step, you can retrace any step you found difficult to solidify this understanding. And at the end, you will be able to use these tables to verify the correct sizing of vents in the field. We know that the engineer, and actually mostly the manufacturer, does this work. But if the contractor decides to make a last-minute change for whatever reason, you have the ability to understand how sizing is affected and impacted.
Sizing of vents for multiple appliances. This is International Fuel Gas Code 2021, Section 504.3. Sizing vents for multiple appliances is similar to the process for single appliances. Table 504.3 1 through 7 are used along with the instruction in Section 504.3. Appendix P is useful for looking up example of a specific configuration. Study tip, Section 504.3 also discuss vent connector, which will be covered in Module 6 along with Appendix P, which is informative on multiple appliances vent configuration. Okay, so we finish vents. Let's take quiz. It's okay if we did not get the correct answer because we will see the correct answer after we finish. A fan is used to remove vent gases from a fireplace at a termination outlet of the flue. The fireplace has dot ventilation. Forced draft, induced draft, powered, natural draft. So what we will use, this is forced draft. A 100,000 BTU per hour direct vent furnace is being installed and the vent is being terminated through the wall next to a window that opens. How close can the vent be the window? Okay, this 100 direct furnace, we will talk 100. It will be 12" I think. 12". For single wall metal connector that connects a naturally vented category 1 appliance to a 6" type P double wall gas vent. What is the maximum appliance output rating that can be installed? The vent is 15 feet tall and the lateral is 10 feet. Okay, for a single wall meter connector that connects a naturally vented category. Okay, I don't know the correct answer, so let's select this one and we'll see the correct answer. An unvented gas set of countertop burners is installed in a 200 square foot domestic kitchen with 10-foot ceiling. What is the maximum output that allowed for gas range? Okay, let's see the correct answer after it will be finished. An oil appliances with a mechanical draft system vent through horizontally next to sidewalk. What is the minimum height required from the sidewalk to the vent. An oil appliances with a mechanical draft system vent through the horizontal termination next to sidewall. Okay. What is the minimum height required for a sidewalk to vent termination? Okay. Only 6 feet. Let's get results. Okay, okay, I know. Let's see. I want to see the result. Yes, this is the result. Number one, a fan used remove vents gas. It is induced draft from a fireplace at a termination outlet. Vent gas. This fireplace has a venting system. Okay, this is induced draft. Okay, okay, so let's take a photo from this one and let's go to the next one. Chapter 2 is the definition of draft. Okay, so this is definition, draft definition. This in chapter 2. Okay, next it will be 12 inch. We answer this correctly. Okay, let's go to the next. This one it will be 190. It's international. This from table backup question single wall. Okay, this one for single wall meter connector that connects naturally vented category 1 appliances to 6-inch type P double wall gas vents. This what is the maximum appliance input rating that can be installed? The vent is 15 feet tall and the lateral of the connector 10 feet. Okay, let's go to the next question. Okay, this one is the correct answer is 40,000. Okay, because an unvented gas set of countertop burning is installed in 200 square foot domestic kitchen with 10-foot ceiling. What is the maximum input rating allowed for gas? As we see here, international fuel gas 501.8 give an allowance of 20 BTU per hour per cubic feet for space of unvented appliances. This means 200 multiplied by 10 is give us 2000, and 20 BTU for 2000, it will give us 40 BTU per hour. Okay, let's go to the next. And oil appliances with a mechanical draft system vent through a horizontal termination next to sidewalk. What is the minimum height required for the sidewalk vent termination? It will be 7 feet. Okay, it will be 7 feet. Okay, this all. We will revise this again and we will check the answers. Okay, that's all for this module of the vents. Let's go back for the module. This is in vents, and that's all about vents.